Activity 1. Introduction of aircraft weight and balance tools and equipment. A. Weight measuring scales. Number 1. Digital scale. Provides precise weight measurements with electronic readings, reducing human error. Number 2. Platform scale. A flat, stable surface used to weigh large aircraft components or entire aircrafts. 3. Axle scale. Measures the weight distributed on each axle, useful for ensuring even load distribution. B. Center of gravity calculators. CG calculation charts, table or graphs. Graphical tools used to determine the aircraft center of gravity. 2. CG computer programs. Softwares that automate CG calculations for efficiency and accuracy. 3. Manual CG calculators. Handheld or manual devices used for quick CG estimations. C. Load planning softwares. Real-time data entry. Allows operators to input and update weight data in real time. 2. Automated calculations. Software that automatically processes weight and balance calculations. 3. Compliance checks. Ensures adherence to regulatory weight and balance limits. D. Weight and balance load sheets. 1. Manual forms. Paper-based load sheets for recording weight and CG manually. 2. Electronic data sheets. Digital load sheets used in modern aircraft operations. E. Aircraft weighing systems. Weighing pads or platforms. Large flat weighing systems placed under aircraft wheels. 2. Weighing pit system for large aircrafts. A specialized system embedded in the ground for large aircraft weighing. 3. Hydraulic load cell. Uses hydraulic pressure to measure the weight of an aircraft accurately. F. Balance equipment. Balance kits. Portable kits used to check weight and distribution and CG location. 2. Jacking system. Used to lift aircraft for weight and balance adjustments. G. Weight and balance documentation tools. Air operating manual contains weight and balance data specific to each aircraft type. 2. Regulatory compliance tools. Documents and software that ensure aircraft weight and balance compliance with aviation authorities.
Now moving on to the next activity called preparation for aircraft weighing. Introduction. Aircraft weighing is a critical procedure in aviation maintenance. It ensures that an aircraft complies with weight and balance regulations which directly impact flight stability, fuel efficiency, and overall performance. This process is especially important after major modifications, repairs, or scheduled maintenance. Incorrect weight distribution can compromise flight safety, making accurate weighing an essential part of aircraft operations. Now moving on to the stated problems. To obtain the precise weight measurements through preparation is necessary. The following key steps must be followed. Number 1. Select an even weighing area. The weighing should take place on a level surface, such as hangar, to avoid errors causing uneven ground. Number 2 is calibrate the equipment for weighing. Only certified properly calibrated aircraft scales should be used to ensure accurate readings. Number 3 is place aircraft in the standard configuration. Remove any loose items that do not contribute to the aircraft's operational weight. Ensures that all required equipment is in its designated positions. Number 4 is empty or fill fluids at exact levels. Fuel, engine oil, and hydraulic fluids should be at manufacturer's specified levels to avoid weight miscalculations. Followed up by extend or retract landing gears as required. If using jacks, ensure the aircraft is properly supported. If using platform scales, on the other hand, all wheels should be centered for an accurate readings. Number 6 is chock wheels and secure aircraft. Use non-load bearings to chock to prevent movement without affecting weight distribution. Ensures all doors and panels are securely closed. Next is controlled environmental conditions, like avoid external forces such as wind or temperature, fluctuations that could interfere with the accuracy of weight measurements. Last but not least is record and verify readings. Take multiple readings and compare them with the aircraft's documentation to ensure compliance with weight and balance limits. Now moving on to the findings. During our aircraft's weighing process, we made several observations that highlight the importance of precision in this procedure. Number one is in the initial inspection, no unnecessary items were found, but structural concerns such as rust, missing rivets, and screws were identified. This could affect the aircraft's integrity. Second is fluid levels. The Cessna has 5.5 quarts less oil while the Beechcraft had a full oil levels. This difference affects the weight distribution. Third is the tire pressure and positioning. The aircraft has very low tire pressure in around 7.9 psi, causing a slight rearward tilt which impact the balance calculations. Last but not least is environmental conditions. The weighing was conducted on a sun environment, reducing the risk of external interference. Now moving on to the individual conclusion. The first student, they said even small factors such as fuel and tire pressure can affect an aircraft's weighing and balance. Said Saville, proper weight calculations are critical for safety and must be conducted with precision. Said Salvatus, the pre-weighing inspection process is essential, including fluid checks, landing gears, assessment, and aircraft's alignment. Now in the statement of Butiong, hands-on experience reinforced the importance of thorough pre-flight inspections. In the statement of Genzon, every step of the weighing process must be followed carefully to prevent safety risk. And the statement of Padrinao, understanding manufacturer's guidelines, including the fluid and tire specifications, is the key to ensure safe aircraft's operations. Now moving on to the activity takeaway. This activity reinforced the importance of proper preparation in aircraft weighing. Attention to detail matters. In a way, even minor factors such as fluid levels and tire pressure can significantly impact the aircraft's weight and balance. Safety is the top priority through accurate weighing helps prevent flight hazards and ensures the aircraft is within the safety operational limits. Teamwork and accuracy as in aviation maintenance requires collaboration, double-checking of procedures and adherence to guidelines to maintain efficiency and reliability. Documentation and compliance in a way recording accurate readings and following manufacturer's specification ensures regulatory compliance and flight safety. Now moving on to the picture of evidence. This is the procedure number 5, number 6, and number 7. So that is all for the activity number 2. Thank you for listening.
Good day, everyone. Today, I will be presenting our activity number 3, aircraft weighing procedure. This activity focused on understanding the importance of aircraft weight and balance, as well as practicing the proper procedures for weighing an aircraft accurately. Introduction. Aircraft weight and balance are fundamental aspects of aviation safety and performance. Accurate weight determination and proper center of gravity calculations are essential for stable flight. Efficient fuel consumption and compliance with regulatory standards. This activity focuses on weighing an aircraft using a structured approach, computing individual net weights, determining the total moment, and locating the aircraft's CG. The process involves measuring the aircraft's weight at different landing gear points, removing tare weights, and applying mathematical formulas to derive the required balance parameters. The results provide insights into how weight distribution affects flight characteristics and reinforce the importance of precise weight and balance computations in aviation. Aircraft weight and balance are crucial factors in aviation safety and operational efficiency. This activity was designed to familiarize us with the systematic approach to determining an aircraft weight, computing individual net weights, and calculating the total moment and locating the center of gravity. Ensuring accurate weight distribution is essential for stable flight, efficient fuel consumption, and compliance with aviation regulations. Stated problems. During this activity, we addressed key challenges, including accurate weight determination, measuring the aircraft's weight at different landing gear points while ensuring precision, calculation of moments, computing the moment for each landing gear by multiplying the net weight by its respective arm length, center of gravity identification, using the total moment and total weight to determine the aircraft's CG location, ensuring proper weight distribution, verifying whether the CG falls within the acceptable limits for safe flight operations. Findings. Upon completing the weighing procedure and performing the necessary calculations, the following values were obtained. Total weight 5,027 grams. Total moment 713,299 grams times millimeter. Center of gravity is 141.89 millimeter. From the reference datum, these results confirm the successful application of aircraft weight and balance principles, demonstrating an accurate and systematic approach to weight distribution assessment. For the solution and computations, number 1, net weight calculation. The net weight of each landing gear was determined by subtracting the tare weight from the scale reading. Example, net weight equals scale reading minus tare weight. Number 2, moment calculation. The moment was calculated using this formula. Moment is equals to net weight multiplied by arm. Number 3, center of gravity calculation. The CG was determined using the equation. CG is equal to total moment over total weight. From our computations, the CG was found to be 141.89 mm from the reference datum, confirming a balanced weight distribution. Conclusion. Through this activity, we have gained valuable hands-on experience in aircraft weighing, applying theoretical knowledge to real-world procedures. It has given us a deeper appreciation for the structured approach in aviation maintenance and the critical role of weight and balance in safe flight operations. That concludes my presentation for activity number 3. Thank you.
Okay, so next po we have the manual center of gravity calculation for activity number 4. So for activity number 4, dito po ay manual calculation tayo ng ating center of gravity. And take note that itong part na to, the center of gravity calculation, is one of the most critical steps in preparing the aircraft, since dito nakadictate or dito nakasalalay yung buhay ng mga passengers natin as well as the crew sa aircraft. So isang pagkakamali lang can potentially take the lives of many. No. So for the introduction, center of gravity is a critical concept in physics and engineering. representing the point where an object's weight is evenly distributed in all directions. Accurate center of gravity computation is essential in various fields including aviation, construction, automotive design, and structural analysis, ensuring stability, balance, and safety. While modern technology offers computational tools to determine the CG, manual calculations remain a fundamental skill for engineers, designers, and students. It provides a deeper understanding of weight distribution principles and serves as a valuable method for verification. So karamihan ngayon, since medyo techy na tayo in this century, meron ng mga tools na ginagamit para mag-compute ng CG automatically. Pero for as verification as well as since itong skill na to is kailangan alam talaga ng mga taong kagaya natin na nasa aviation field, kailangan talaga natin matuto ng manual calculation ng center of gravity. So for the stated problems, consider an airplane having an empty weight center of gravity of 1,340 pounds at positive 37.0 inches, maximum gross weight of 2,300 pounds, while front seat is occupied by a 63.49 kilogram pilot and a 52.15 kilogram passenger at positive 35 inches. The rear seat is occupied by two passengers, 96 to 15 kilograms and 44 kilograms at positive 72 inches. There will be a 22.68 kilograms of baggage at positive 92 inches, and the flight is to have a maximum range, so maximum fuel of 40 gallons at positive 48 inches is carried. CG limit is set at 35.6 inches to 43.2 inches. So, ang mga given na yan is basically our weight as well as the arm. No? So, findings is of course yung, siyempre nilist down na natin yung mga given natin. So, included doon yung aircraft empty weight and center of gravity, maximum gross weight, front seat occupants, rear seat occupants, baggage, fuel load, as well as the CG limits. So, para mas madali natin siyang masagutan, gamit tayo ng table. So, for hatiin natin siya sa apat, which is the item, the weight, the arm, the moment. So, the items are the empty weight, the front seat occupants, the rear seat occupants, the baggage, the fuel, and the total. So, for the weight, kailangan natin siyang gawing pounds. So, yung mga given natin na kilograms, i-multiply natin sa 2.2046 para makuha natin yung pounds niya, or LBS. So, and the arm naman is given na positive yun, forward. Pag negative is aft. So, next is the moment. So, moment, para makuha yung moment natin, i-multiply na natin si pounds or si weight sa ating arm. So, 1,340 pounds times 37.0 inches is 49,580 pounds per inch. So, gagawin na natin yung lahat sa items natin. So, lahat ng ito times sa lahat ng weight ay ito times arm para makuha yung moment. So, after that, ito-total natin yung weight para makuha yung total weight and the total moment. Since para makuha natin yung center of gravity, kailangan natin siya kailangan natin kunin yung total moment as well as the total weight. So, for the formula of center of gravity, so total moment over total weight, so total moment natin is 97,973 pounds inch, while total weight naman natin is 2,195.7 pounds. So, ang sagot nun is 44.6 inches. Now, sabi kanina, yung CG limit ng ating aircraft is 35.6 inches to 43.2, and yung sagot natin is 44.6. So, the computed CG exceeds the aircraft CG limits. So, this means the aircraft is outside the aft CG limit, making it unstable in flight. So, this activity has some conclusions. No? So, for the conclusions, with the help of this activity, I was able to recall my knowledge in manually calculating the moment and center of gravity of an aircraft. Additionally, I was able to understand the importance of knowing how to calculate the center of gravity, as it is a major step in making the aircraft safe for flying. So, a takeaway for this activity is this activity highlights the importance of center of gravity computation in ensuring aircraft stability and safety. Understanding how weight distribution affects flight performance is crucial, as exceeding CG limits can lead to instability, difficulty in control, and potential safety hazards. Manually computing the CG reinforces fundamental aviation principles and helps pilots, engineers, and aviation students to develop a structured approach to weight and balance calculations. Additionally, this exercise emphasizes the need for proper weight management, such as adjusting baggage placement or passenger seating to maintain center of gravity within safe operational limits. Mastering these calculations is essential for flight planning, risk mitigation, and overall aircraft performance optimization. So that concludes our group's online presentation. I hope everyone enjoyed, as well as I hope everyone learned a lot from our group. Thank you so much for watching, everyone, and I'll see you next time. Thank you.